Day 9 of 60. Today we are covering alerting strategies, and I want to start with an honest statement: most alerting setups are broken. Not because Prometheus or Alertmanager are bad tools, but because teams alert on the wrong things. I have seen organizations with 2,000 alerts per day where the on-call engineer just mutes the channel. The real incidents get buried under noise and nobody responds. Today I am going to walk through the strategies that actually work in production. The most important concept in alerting is the difference between symptoms and causes. A symptom is something users experience: error rates going up, latency exceeding your SLO, requests timing out. A cause is something internal: CPU at 80%, a pod restarting, disk approaching capacity. You page on symptoms, never on causes. When your error rate spikes, that is user impact and someone needs to investigate. When CPU hits 80%, that might resolve on its own or be completely expected during a batch job. Cause-based metrics belong on dashboards, not pager alerts. This shift from cause-based to symptom-based alerting eliminates the majority of alert fatigue. Now let us talk about multi-window burn rate alerts, which are the gold standard for SLO-based alerting. A burn rate measures how fast you are consuming your error budget. If your SLO is 99.9% availability, you have a 0.1% error budget per month. A burn rate of 1 means you will exactly exhaust your budget at the end of the period. A burn rate of 14.4 means you will blow through your entire monthly budget in just 1 hour. The multi-window approach pairs a long window with a short window. For critical alerts, I use a 1-hour window and a 5-minute window. Both must exceed the threshold. The long window provides statistical significance and avoids alerting on brief transient spikes. The short window confirms the problem is happening right now and you are not reacting to stale data from an incident that already resolved. For warnings, I widen to 6 hours and 30 minutes. This catches the slow burns that will exhaust your budget over days. Alertmanager is where your routing logic lives. The routing tree determines who gets each alert and how. Critical alerts go to PagerDuty with a 10-second group wait. Warnings go to a dedicated Slack channel. Info-level alerts hit a low-priority channel for triage during business hours. But the feature that saves on-call sanity is inhibition rules. An inhibition rule says, if this source alert is firing, suppress these target alerts. The classic example is a cluster-level critical alert inhibiting all warning-level alerts for the same cluster. When a node dies, Kubernetes reschedules pods, health checks fail, and suddenly you have 40 alerts. With inhibition, you get one, the cluster-level critical that triggered everything. The other 40 get suppressed until the root cause clears. I also configure a dead man switch using the watchdog pattern. This alert fires continuously. If it stops, your monitoring pipeline itself is broken. Route it to a webhook endpoint that alerts through a separate path if it stops receiving pings. Let me cover 3 techniques for reducing noise. First, recording rules. Instead of computing expensive PromQL aggregations at alert evaluation time, pre-compute them on a 30-second interval and store the result as a new metric. Your alert rules reference the pre-computed metric, which evaluates instantly and consistently. Second, the for clause. Adding for 5 minutes to an alert rule means the condition must persist for 5 minutes before firing. This filters out transient spikes that self-resolve. Be careful not to set this too long on critical alerts or you delay your response time. I use 2 minutes for critical, 5 minutes for warning, and 15 minutes for info. Third, the absent function. This catches silent failures where a target stops reporting entirely. If your API server metric just vanishes, rate of 0/0 returns nothing and your error rate alert never fires. Absent catches this by alerting when the expected metric does not exist at all. For PagerDuty and Opsgenie integration, the Alertmanager config handles the webhook side. But the escalation policy on the PagerDuty side is equally important. I set a 5-minute acknowledge window for the primary on-call, then escalate to secondary after another 10 minutes, then to the engineering manager after 15. 3 escalation loops. If nobody has responded after 90 minutes total, that is a process failure you address in your post-incident review. On the scheduling side, weekly rotations work well for teams of 4 or more. Always have a primary and secondary. For distributed teams, use follow the sun so nobody gets paged at 3 a.m. And every on-call rotation needs a handoff ritual. The outgoing engineer briefs the incoming engineer on active incidents, recent deployments, and anything to watch for. Let me wrap up with the rules I follow. 1. Every paging alert has a runbook link. No runbook, no page. 2. Alert on symptoms, investigate causes second. 3. Use multi-window burn rates tied to SLOs instead of static thresholds. 4. Configure inhibition to prevent cascading noise. 5. Test your alerting pipeline by triggering alerts in staging. Follow these 5 rules and every notification will be worth investigating. Day 9 done. Tomorrow we cover incident management. See you then.